So next on our list of tasks is to create that very important class that acts as the bridge between our code and our database, and that's the DB context class. So what we'll do in our API project, a little bit of folder management, we'll create another new folder, and this one we'll simply call data. Any data related classes are going to go inside this folder. So what we'll do is we'll create a new class and we'll call this data context. And what we're going to do inside here is we're going to derive from the DB context class, and we get this from entity framework. So what we should be able to do is we can immediately see a red squiggle underneath the DB context, and if we hover over the squiggle, then it says the type or namespace DB context could not be found. Are you missing a using directive or an assembly reference? Whenever you see an error, always put your mouse over it, hover, take a look at what the error actually says. Now, in order to use the DB context class, we need to tell our class what namespace it is in. Now, our data context class lives in the namespace API data. Now, this relates to the folder that we created the class in. If we look at the folder, we can see that we're inside the API, the data folder, and then the data context class. Now, this is a logical name. It doesn't have to be called API.data. It's just how it is called based on the folder that we create, and it's a good way to keep your namespaces organized. You could call it, if you want, API thing, which doesn't mean anything, and you're not going to get any complaints, but you would need to import it or add a using statement for API thing. So we're not going to do that. We're going to keep our namespaces matching what our folders are. So do be careful if you create a file or a class in the wrong place, then do remember to update your namespace to match what folder it lives inside. Now, with our cursor over the error, what we can do is we can see a light bulb over on the left-hand side, and this gives us the option to show fixes. And it tells us the shortcut key combination to do this, which in my case is Command and period. I think it's Control and period on Windows, but do double check whatever it says there. And then what we can do is press the Command and period in my case, and it will give us an option to say using Microsoft Entity Framework Core. And if we click this option, then it adds a using statement to our class and the error goes away. What we see then is a description. If we hover the mouse over DB context, we see a description of what this class does. And it tells us that a DB context instant represents a session with the database and can be used to query and save instances of our entities. And it also gives us more information than that. But that's all we need to know for now. And what we want to do inside this data context class is create a constructor. Now what we can use is the quick fix for this. If we put our mouse inside data context, when we can press the quick fix, and then we can generate a constructor, and we've got two different options here. VS Code is smart enough, or the C# extension is smart enough to look inside the DB context class and see what different constructors it has available. And one of them is to generate a constructor called data context options. If we click on this, then it gives us a constructor. When this class is initiated, then the constructor is called. And what we need inside this constructor is literally what this is. We don't need to add anything to this. We can just leave this constructor as it is. If we forget to add it, we'll get an error. And we'll be passing some options to this particular class when we add it to our startup configuration, where we add it to our dependency injection container. We'll talk about that soon. But for now, we just need this particular constructor. What we also need to add inside this class is a DB set. So what we'll do is we'll add a prop, and this is going to be of type DB sets. And this takes the type of the class that we want to create a database set for. And in this case, it's our app user class. So we specify app user, and then we'll go ahead and we'll call a table inside our database users. And we'll need to bring in the app user from API entities. So once again, use the quick fix and specify using API entities. So this is all we need for our DB context class at the moment. What we need to do next is add this configuration to our startup class so that we can inject the data context into other parts of our application. So what we'll do, and another keyboard shortcut that's very useful to get used to using, is the go to file. So Command and P to bring up the search window, and what we're looking for is our startup class, and press return. Now, of course, you can go ahead and go and look for this inside Solution Explorer, but as your files get busier and your folders get bigger, it's much quicker just to search for the file as long as you know the name you're looking for, and in this case it's the startup class. So as I mentioned, what we're going to be using for this is, because we know we want to inject this into other parts of our application, we're going to use our configure services method here. And what we're also going to need to do is create a connection string for our database. So what we'll do is, inside our container here, and the ordering of what we put in here is not so important. So what we can do is specify services, and we can say add DB context and get this from the list. And what we need to specify in here is the name of the class that we created that derives from the DB context. So in this case, it's the data context class. Please be careful with this. Don't use DB context here, otherwise you'll definitely get an error. And what we want to do inside here is pass this some options. So we'll specify options, and we'll add an arrow, which is obviously just an equals and forward angle bracket, and then open up some curly braces. Now, what we're using here is referred to as a lambda expression. The options is the parameter that we then pass to a statement block, which we have inside the curly brackets. And these are very commonly used in C#. If we want to pass an expression as a parameter, then we typically use lambda expressions. And we'll see this a lot throughout this course. And then what we'll specify is options, and then we can say use SQLite in my case, and we'll need to say using Microsoft Entity Core to bring this in. And then what we need to do is pass this a connection string. And if you're not sure what to put inside a method, if I've just got use SQLite here, I take away the parenthesis, then I start typing the parenthesis, then what we get is a description of what this takes. Now, this has 3 different overloads. There's 3 different options about what we can provide as arguments to this particular method. And the first overload here is for SQLite options actions. We're not interested in that. The next one is the connection string. So this is what we'll be passing to the use SQLite method so that it can actually connect to our database. Now we're going to specify our connection inside our configuration. So for now, I'm just going to specify a string that's not going to do anything for us and just call it connection string. And we'll update this very soon. And then just finish off by adding the semicolons where necessary at the end of a statement and at the end of this statement as well. And what we'll do next is we'll take a look at our connection string and actually creating the database based on the code that we've written so far. What we're going to do now is use a connection string or add a connection string for SQLite so that we can actually connect to our database from our application. And the way that we do this typically is we add this to our configuration files. Now we've got 2 configuration files that we've got access to in here, as well as our environment variables. But whilst we're developing our application, then it's convenient to use our app settings development.json, where we can store things that we don't mind other people seeing. Now, when I say that, a SQLite connection string doesn't contain any password information. We don't supply it with any confidential information, so it's something that I consider safe to be inside a file that when we look at source control later, I'm okay with this going publicly onto the internet because I don't care what people see as my SQLite connection string. So just at the top of this file, what I'm going to do is open some quote marks and specify connection strings, and this needs to be pluralized. I'll explain why, but this needs to be spelt exactly as I've written it here. So we need connection strings there, and then what we'll specify is the default connection we'll specify as data space source equals, and then I'll just call it datingapp.db and add a comma to remove the error. So the name here is essential that this is spelt correctly, and because we're dealing with strings, of course, then please be careful about the spelling of the second part as well. Now, SQLite connection strings are super simple. No password information, no user information, simply the name of the file where we want to store our database. And I've just given it a simple name. Could be called anything you want. And .db is just the file extension that's going to be used. Please no deviations from this connection string. It is simple, but this isn't going to work putting a dash there or any other fancy shenanigans that you want to add here. Please be accurate in what you call your database. So what we need to do is pass this configuration into our options that we added earlier to our startup class. Now, we're injecting our configuration into the startup class, but I don't particularly like the way that Microsoft have done this, and we'll follow a slightly different way of specifying dependency injection. Now, our configuration comes from a class called iConfiguration, and the way that I prefer, and it's very common, other developers prefer to do it this way too. It's not just me that's got a moment of madness here. Other people use this same convention. So what I'll do is I'll just remove that line, and inside the configuration string here, I'll actually just shorten this to config as well, just because it's easier to type. I'll just put my cursor inside config, use the quick fix once again, and what we want to use is this initialize field from parameter. Now, I also don't like the way that this has specified this. We don't need this second line anymore either, so I'll just remove that. But I don't particularly like the use of this inside constructors. We don't need it, but we do need it if this is called this. What's common to do is to add an underscore to the config and then say underscore config equals config. So we have a private read-only variable, and we access this configuration via this property when we want to use it in our class. When we construct this class, the iConfiguration is being injected into this class when it's constructed. And that means we'll have access to this configuration wherever we need it inside this class now by accessing this private variable. However, I also don't particularly like having to remove the lists and type in the underscore every time either. So what we'll do, we'll just go to code and go to preferences and go to settings, and inside settings just search for private, and we've got an option here for a private member prefix, and this comes from our C# extensions. So what I'm going to do is just specify the underscore inside there. And what I also want to do is remove the lists keyword as well when I use that initialize field. So I'm just going to search for lists in the search bar there, and this is a C# extensions configuration property as well. And we've got an option here whether or not a constructor assignment of a property should be prefixed with this. It's enabled, and I'm just going to turn that off. And if we go back to our startup class, then let's just make sure this is working. I'll just remove the private read-only from there and also remove this. And if I go and do the same again and I say initialize field from parameter, this time we get what we're looking for. We've got the underscore config and we've got it set correctly there as well. So now with all that in place, what we can do is actually make use of the configuration, and inside our options SQLite we'll say underscore config, and then what we can do is say get connection string, and this is shorthand for get section. And this means we're just going to get a section from our configuration files, and it's going to look for something called, very specifically, connection strings and then its name. So we need get connection string, and inside here we're going to target the default connection. And now we've got our configuration set up so that we can access our database via this particular connection string. Now, in order to actually create our database, what we need is to install a tool onto our computer to help us do so. And what I'm going to do, I'm just going to go across to Chrome, And we can't install this one via the NuGet gallery that we installed earlier. We need to install this via a command line. And to help us out with this, I'm just going to go to nuget.org. And what I'm going to search for here is .NET-EF. And we're going to click on .NET-EF inside here. Now what we want to use here is the tool that matches the version of .NET-EF or entity framework that we installed earlier. Now I'm using version 5.0.0 preview 8. You may have installed a later version than me, so please come to nuget.org, search for .NET-EF, and then copy the command from here. If you're using an earlier version, then please just go ahead, look at the version history, and select the appropriate runtime. For example, if I was on 3.1.7, then this gives me the commands to go ahead and install it. Please copy it from this. This has caused other students issues in the past trying to install this tool. It's very fussy, and it does need the exact command with no deviation, otherwise it causes issues. So we'll just copy this, and then we'll go back to VS Code, and we'll open up the terminal, and I'll just go into a new terminal session, and I'm just going to paste in this command. It's a global tool, so we don't need to worry about what folder we're in, and I'm just going to press return, and this will go ahead and install it. Now I've already got it installed, so I didn't actually need to go ahead and do that, but you will need to obviously install this on your computer. Once we have this installed, what we can then do, and I'm going to use the first terminal where I'm running my application, because we do need to stop our application to run this command. And I'm just going to clear the screen here. And what we want to do is we want to create a migration. And the migration is going to take a look at our classes and create a database schema, or the code to create a database based on our code that we've written so far. So what we'll do is we'll use the .NET-EF tools, and we'll say .NET-EF migrations add, and we'll just call it initial create. And what we'll also do is give this an output folder, because this is going to create a new folder on our project anyway called migrations. And what we'll do is we'll specify -o and then data and then / migrations. Again, I believe you might have problems if you don't call this migrations. I'm sure I've seen an issue before with a student who had an issue because they'd called it migration instead of migrations. So go ahead and press return, and we get an error. Now this is an example of a good friendly error, and it tells us that our starter project, the API, doesn't reference Microsoft Entity Framework Core Design. This package is required for the Entity Framework Core tools to work, and ensure our starter project is correct, install the package, and try again. Now this is something that we can read, and without needing to go to Google or anything else, we can pretty much instantly say, aha, I know what I need to do here. And that's to copy this line for the name of the package, say, okay, we don't have this installed. What we'll do is we'll open up the NuGet gallery. So open the command palette tools and search for NuGet, open the gallery, and then just go and paste in what we're looking for. Microsoft Entity Framework Core Design. Once again, I'm going to click on the pre-release because I'm using the preview version of .NET 5. Tick the API project and go ahead and install. And this has gone ahead and installed that package. Now what we should be able to do is go back to the first session, and we can repeat the commands to create the migration. So I'll do that, and I'll press return. And this time we get success. So what has this actually done for us? Well, let's go take a look. And inside our project files, what we'll now have inside our data folder is a migrations folder. And there's one class we want to take a look at here, this initial create. These other two files are for keeping track of where we are, because we can create multiple migrations and update our schema of our database incrementally. But the one for this particular migration is the initial create. And if we take a look at what this is going to do, this has got two methods. What to do going up and what to do coming down. And what it's going to do when we run the command to update our database, it's going to create a table called users. It's going to have two columns, the ID column and the username column. The ID column is going to be an integer, and because it's called ID, this is also our primary key for this table, and it's also going to auto increment this every time a new record is created as well. And all of this is taking place by convention. We didn't need to tell Entity Framework that the ID was our primary key. Conventionally, it knows that anything called an ID, unless we tell it otherwise, should be our primary key. And we've also got a method that should we remove a migration, then we've got the down method, which is just going to literally drop the table in this case. And what we're going to take a look at next is actually creating the database. Okay, now that we've got a migration, what we can do next is actually go ahead and update our database. So what we'll do is we'll just go back to our terminal window, and I'll just clear the contents of this screen. And in order to create our database, we can once again use the .NET EF tools. And this time the command that we're going to use is the .NET EF database, and then update, and press return. And it goes ahead and creates our database. Now we can see what's gone on here. And just to point something out here, by the way, what this does, this command, before it goes ahead and does the database creation, it builds our application. And if you get an error such as build failed, please make sure you've stopped your API from running before you try and do this. Otherwise, you'll get an error, and it's not very descriptive. So first of all, it builds our application, and then it goes ahead and reads from our migrations, and it creates our table. Or first of all, it creates a table called EF Migrations History. This keeps track of the migrations that have been applied into our database. And then if we scroll further down, we can see that it creates a table called users, and it's got two columns, the ID and the username. And then it inserts a record into the EF Migrations History database with the name of the migration along with the runtime that was used when creating that particular migration, or the version of the Entity Framework tools, I should say. So how do we go and check physically to see that we've got a SQLite database? Well, what we can use is we'll head back to VS Code extensions, and this time we'll use SQLite. Visual Studio users, Rider users, you'll have your own tools to manage a database, and for VS Code we just need to install an extra tool. This tool is fine, you've got various different options, but this one called SQLite is sufficient for what we need inside here. So I'm just going to go ahead and install this, and then I'm just going to close all, and what we can do then is open up the command palette once again, and we can use the SQLite and say open database, and then it's going to look inside our project. It's going to find the database file that was created when we created our database, and we could select that. And if we go and take a look at our project files, what we'll find is that, well, it's actually created 3 files, the dating app DB and a couple of SQLite extras that we don't need to look at, but they're there anyway. So don't worry about those. But inside Solution Explorer, we've got the SQLite Explorer, and we can see our database, and we can see our table for our users with an ID field and a username, and also the EF migration history. So that we've got some data to work with, what we'll do is we'll use this tool to insert some data into our database. We'll look at more sophisticated ways of getting data into our database a bit later on, but in order to keep things simple and to keep us moving, we're just going to use this method to insert some data. So what we're going to do is right-click the users table and say new query insert, and then we can literally write SQL commands to get some data in there. And what we'll do is we'll insert into our users table, and we'll just give it an ID of 1, and we'll just add a couple of usernames inside there, and we'll add Bob as one user, we'll add Tom as a second user, and we'll just copy this command a third time, and we'll add a value of 3, and we'll specify Jane as the third user inside here. And then what we can do is just highlight all of this code, right click and say run selected query, and this goes ahead and executes these commands and updates our database. And what we should find is we can close this down. We don't need that anymore. But what we should find, if we right click and show table, we now see that we've got 3 different records in our database. We've got Bob, Tom, and Jane, along with the 3 IDs as well. So we've now got data in our database. What we'll take a look at next is creating an API controller so that we can fetch the records out of this database and send that data back to the client. What we're going to take a look at now is adding our own API controller. And if we just go back and take a look at the weather forecast controller one more time, then we're going to see some features that each API controller actually has. Now, if we take a look at some of the features that we need inside an API controller, first of all, we have this thing in square brackets called API controller. Now, this signifies that this particular class is of type API controller, and there's certain things this adds to our controller that we'll talk about shortly. We won't worry about it for now, but we'll just add that because it's in this one, and then we'll take a look at what it actually does for us a bit later on. We also need a route for our API controllers. How is the user going to get to the API controller from the client? And also, a controller needs to derive from a controller base. And if we hover over the controller base, then it tells us what it does, a base class for MVC controller without view support. So what we'll do, we'll just go into our controllers folder and we'll create a new class, and we're going to call this one users controller. And specifically the pluralized version of users, because the route to get to this controller will be users, or in our case we'll call it API users. So the first thing we need to do is derive from controller base first of all. Then we'll use the quick fix to say using Microsoft ASPNET Core MVC. Now MVC stands for the old-fashioned model view controller, and our API controller is a type of controller. The view is going to come from our client. We're going to be using the Angular to provide the view of our application, but MVC has been around for some time, and that's the way of using .NET to serve the HTML pages, but we're going to be using Angular for that. So the C is what we're using in this case for the controller. And what we also need to do is give our controller some attributes, and one is the API controller and the other one is the root. And the root in this case, all of our API controllers, we're going to say start with API, and then we'll use the square brackets and we'll use the controller placeholder. So in order to get to this controller, the client's going to need to specify API / and then users. Now what we want to do in this controller is actually get some data from our database, and to do that we're going to use dependency injection once again. So what we'll do is we'll put our cursor inside the users controller and use the quick fix to generate a constructor for the users controller. And then what we're going to do is specify data context and say context, and we'll need to bring in data context from using API data and make sure this has been added in successfully, which it has. And then we'll use the quick fix again to initialize the field from parameter. And now inside this class we have access to our database via the DB context just by using _context. Now what we'll do is we'll add 2 endpoints in here. We'll add an endpoint to get all of the users in our database, and we'll add another endpoint to get a specific user in our database. And just as the weather forecast controller, we'll use an HTTP GET because we're getting data in this case. And then what we'll use is we'll say public, and we'll return a type of action result. And then we specify the type of thing that we're going to return inside this result that we send back to the client. Now in this case, we're going to be sending back a list of users. And there's several collections inside .NET for returning lists. But what we're going to use here is an IEnumerable of type app user. And we're just going to call a method get users and open up the curly braces to say the statements that we're going to put inside this method. Now we'll need to bring in using system collections generic to make use of the IEnumerable. And we'll also need to bring in API entities to make use of the app user class. Now, an IEnumerable allows us to use simple iteration over a collection of a specified type. What we could have used instead is we could have just used a list, and list will do the same thing. It will return a list of users, but a list also offers methods to search, sort, and manipulate lists. And it offers too many features for what we're doing here. We just need a simple list that we can return to the client. And the IEnumerable is a more appropriate type in this case. So that's the one we'll use. And what we want to do here is we'll create a variable to store our users in. And we'll say var users is equal to context.users. And then we can specify that we want to get our users from the database into a list. And in order to use the toList, we need to bring in another framework class or namespace and say using system.link. And then what we can do is just return the users from this endpoint. Pretty simple. What we'll do, just to be lazy, and I do this sometimes, is when something's going to be fairly similar, I'm just going to take a copy of it and drop it below and make a few changes. And this method, this second endpoint, we just want to get an individual user and we want to get it by their ID. So what we can add is quote marks and then curly brackets inside, and we can specify a root parameter. So when somebody hits this endpoint, what they're effectively doing is saying API/users /2 or 3, and this is going to get the user with the ID of 3. Now when the user hits or the client hits this endpoint, 3 in this case is going to be the ID of the user that we're going to be fetching from the database. So what we'll do is we also need to pass that in as a parameter here to the getUsers method, which I'm going to rename to getUser. So our getUser is going to take an int of an ID, which we get from the root parameter. And then in this case, instead of users, I'm going to swap this for var user. And then we're going to use a different method from our context. And we've got one here called find. And this finds an entity with the given primary key from our database. So we'll use find and we'll just pass in the ID and then we'll just return the user. And we also get type safety here because I'm getting an error, and if we hover over the error, then it tells us that it can't implicitly convert a type of app user to a collection of users. And that's because I need to remove the IEnumerable here and just specify that we're returning an app user in this case, and the error goes away. Now, we don't need to do this on two separate lines. There's actually no need to declare a variable to store our user if we're not doing anything with it. And what we can do instead is simply return the result of the operation. So we can reduce our code to a single line in this case. And we can do the same above as well. If we don't need to do anything with the users before we return them, we can simply return the result of the database operation. Now, what we should find now, if we go to our browser and we go and make a request to localhost 5001, and then we'll need to specify the root endpoint. So in this case, it's going to be API users. Then we get the site cannot be reached. And the reason for that is I didn't actually start my API after I updated the database. So what we need to do is say .NET run to do so. And that goes ahead and starts our application. So if I go ahead and I refresh the page, then what we should find is we get our list of users. And if I specify a single user and say /2, then we just get an individual user returned to our browser. But using the browser is not the most efficient way of testing things are working in our API. And one of the tools we installed earlier on was Postman. And let's go take a look at Postman. So I'm going to open this up, and what we could do in Postman is literally do the same as we're doing in our browser, but we get the response back in a more friendly way and easier to digest in Postman. So what I'm going to do is I'm going to make a new request inside here, And we're going to go to localhost colon 5001/API/users and press return. And then we see that our response comes back in, and this is JSON format. And we can see we've got our ID and our username inside here. Notice that the API by default returns the responses back in camel case, lowercase I for the ID and lowercase u for the username. And that's a default convention that most APIs do, and Microsoft follows that because JSON formatted code is typically in camel case. Our classes in C# are in title case, but we see this in camel case in our results here. And what we should also do is just double check that we can see the individual results, and if we go to API users 1, then we can see that we get the ID and username of Bob back there. So it's working. We can get our data from our database via our API controller. And we've got some relatively simple goals at this stage, as our walking skeleton just requires us to see the end-to-end functionality. And we do have our users coming back into our client, and our client is Postman in this case, and we can see the results. Obviously, we're going to take it a step further in the next section and introduce Angular, but this is pretty good for what we're doing so far. What we're going to take a look at next is take a look at asynchronous code, because what we're doing now is asynchronous, and we'll take a look at async code next. So we're returning data from our API, but when it comes to scalability, then what we're doing here is not really best practice, because what we're doing here is synchronous code. And what this means is that when we make a request that goes to our database, then the thread that is handling this request is currently blocked until the database request is fulfilled. Now, in our case, it's hard to justify this because of the data we have at the moment and what we're doing with this data. But imagine we had a really complex query that went to the database. It had to fetch a certain number of records from a database table that's got 5 million records in it, and we needed to sort them and filter some of them and just bring back some queries, do some data manipulation in some way from the database, then our database query might take several seconds, it might take longer. And if we're blocking a thread for that particular database operation, then that's not a good thing. Now, in modern web servers, they are multi-threaded. And let's say, for example, you've got an Apache web server and it's got 100 threads available. You're thinking, well, that's no problem. I've got 100 threads to work with. Why can't one of them just wait for the data to come back? And the answer to that is, well, it's kind of wasteful. Imagine if you had 1,000 users, then your application can only serve 100 at any one time. And it's wasting the resources that are available. So what we can do is we can make our code asynchronous, and we can tell our thread, in this case, when you go to the database, pass this request onto another thread. Let that thread go and deal with getting the data, but in the meantime, if anybody else hits this particular endpoint, I'm going to serve that request, and if they also want something from the database, I'm going to pass that off to another thread as well. And what this means is that our application is instantly more scalable because we make our code, especially our code that goes to the database, we make it asynchronous. And the general guidance is that if you are making database calls, always make that code asynchronous, because it's a negligible performance hit and it instantly makes your app scalable. And if you don't do it and your app surprisingly gets a lot more customers than you're expecting, then you've got to refactor a lot of code and you may experience some awkwardness as you tell your customers to be patient whilst you're waiting to get their data. So what we'll do is we'll take a look at how we can convert this code into asynchronous code. It's not a big effort and it is best practice to do so. So what we need to do to make something asynchronous is, first of all, we specify the async keyword. And then what we do, we want to tell it our code, our method. And what we see here is what we're returning. At the moment, we're returning an action result, but what we need to do is wrap this in a task. So we'll specify task, and then we'll wrap our code here in angle brackets. Now we get a warning saying that the type or namespace task could not be found, but we know how to solve this by simply putting our cursor inside the task and seeing what options are available. And there's an option to say using a system threading tasks. So we'll select that and the error goes away. But now we get a warning. We get a warning saying that this async method lacks await operators and will run synchronously. So we've got a bit more work to do. We need to tell this line of code that we want to wait. And the way that we do that is by using the await keyword. Now we get another problem because our toList method is not an asynchronous method. So we need to use the asynchronous version of the toList, and we'll specify async. And the asynchronous version actually comes from a different namespace, and we need to bring in using Microsoft Entity Framework Core to make use of this. And now what we're doing is returning this list of users asynchronously. So when a request goes to the database, this code pauses. It waits. It's deferred it to a task that then goes and makes the query to the database. When this task comes back, we need to get the results out of the task, and we do that by using the await keyword. There are other ways to get responses back from a task, and we see the error here. So if we add the period, we'll see a list of different options that we get with a task. And what we can use, for example, we wouldn't do this, is just add result and that will make the error go away. But what we would always use in this circumstance is the await keyword. That's the appropriate thing to use here. And to get the result of a task, then we await it, and then it's going to unwrap itself from the task and return our list of users. Now we'll also do the same for the app user as well. We'll just say async task and wrap our action result inside angle brackets, and then we'll use the await keyword, and then we'll use the find async method in order to get the user. And what we should find, if we just go back and test again in Postman, we've got our history of our requests. So let's take a look at the API users and click send, and we still get our users, and what we should find is that if I pick a different user, nothing actually changes. We still get our user. Because our application is so small, it's very hard for you to see any difference whatsoever. And this is really just a scalability thing. It's always recommended to use asynchronous code whenever possible, and that's the way we're going to build our application. So for the walking skeleton purposes, we've just about finished the code for this section. And what we'll take a look at next is how we can save our changes into source control. Okay, we've written a bit of code now, we've created a database, and what we want to take a look at now is saving our changes into source control. There are numerous reasons for doing this. First of all, it gives us a backup of our code. Secondly, it gives us version control, and we can see a history of our code as we develop our application. And another big reason for this is it makes our code shareable. We can publish our code onto an open source Git repository, a source code repository, where we can share our code with others, get feedback from others, we can collaborate with others. But for the purpose of this course, it gives us a place to back up our code. And if you want to continue this course on a different computer, then it's very easy to go and get your code and clone it onto your new computer. So what we'll use for this is we're going to use Git. It's the most common source control software that the vast majority of developers use. And if you come to git-scm.com, just download the latest release for your computer and go ahead and install it. What we'll also do is we'll use GitHub. So also come to github.com. If you do not already have an account with GitHub, please do go ahead and create one. It's free to do, it costs absolutely nothing, and it's a safe place for you to store your code and have it readily available as a backup, like I say, should you wish to share it with someone else, or if you just want to share it with yourself when you move from computer to computer. We'll be pushing all of our changes as we develop our application onto GitHub so we can access it from literally anywhere in the world. So you'll need these two things to start with. So please pause the video if you have neither or only one of these. and go ahead and create your account, you'll need to obviously go through some verification steps with your email address for GitHub. So it'll probably take a few minutes, but once you've done that, then come back and I'll show you what else we're going to be doing. And what else we're going to be doing is going back to VS Code, and we're going to open up our terminal once again. Now, I'm going to go into a different session of this. We want to be inside the solution folder, the dating app folder that I created before. And inside here at the moment is just our API project and the solution file. Now, if you've got Git installed, then what you should be able to do is say git status, press return, and you should see this, fatal, not a Git repository or any of the parent directories. Now, at the moment, what we have, our solution folder is not currently a Git repository. So what we want to do is initialize this. And what we can do is type in git init, and then this initializes a repository in our project folder. Now, it's inside a hidden folder called .git, so unless you've got hidden folders displayed, you won't physically see this in your file system, but it is there. Now, inside VS Code, what it's automatically done is picked up the fact that we've now got Git installed, and it's listed all of the files that have changed inside this folder. Now, there's stuff inside this folder that we don't really need to store in source control. If we take a look at the files that are listed inside here, we can see a lot of them are coming from a bin folder and the obj folder that we hid earlier on, or at least I did. And none of these we need to store inside source control because they're automatically recreated any time that we build our application. So what we want to do is ignore those files. Now, inside the .NET CLI, if we just take a look at the help options once again and just say .NET new -h and see what we have available, one of the things that we have available inside here is a git ignore file. And we can create one of these for our projects that's automatically going to exclude some of those folders. So let's use this to create the git ignore file, and we'll say .NET new and then git ignore and press return. And notice what's automatically happened there. Our number of changes has dropped down to 19 because in that git ignore file, it's ignoring the bin folder and the object folder. If we go and take a look at the git ignore file that was created, then we can see all of the things that are being excluded from source control. And we can see that we've got the bin folder and the object folder being excluded there. Now, another thing that we might want to exclude from Git is our app settings.json file. There's nothing controversial in there at the moment. There's nothing secret that we've added just now. But when it comes to adding API keys a bit later on, then instead of using our development file, we'll store confidential keys inside this app settings.json file. Now, like I say, we're going to be pushing our code into a public GitHub repository. And that means anyone on the planet can see the code that we write, and also any API keys that we might store inside our app settings.json file, they would also be published to GitHub. So what we'll also do is we'll add an entry into our git ignore, which is incredibly large actually. And we've got like 433 things inside here, but what we're also going to add is our app settings.json file, and just add a line for this so that this is also excluded from GitHub. Notice how that this has now turned gray, which means it's not going to be tracked by our source control and will not be pushed into our public repository that anybody can see. So we're going to consider our app settings.json file as a safe place to store any API keys because they're only going to be located on our own development machine. Now, we can manage Git via the command line, but VS Code also gives us some tools to work with this as well. And we'll just review the files that we've got here, and this all looks good to send up. We don't necessarily need our datingapp.db file going up. So you could also exclude that as well. I'm not going to bother because it's harmless, it's not particularly big, and it's fine to go up there. But what we could do then is we can, on this changes element, we can click this plus button, And this is going to stage all of the changes that we've made, ready for committing into our source control. So these are just staged at the moment and are ready to be committed. And what we can do then is give this a commit message. And I'm just going to give it a commit message of saying end of section 2. And then what we can do is use the ellipses here, and we can say commits and commits. And then all of our changes are now committed into source control. What we could do next is we can go back to our browser, and what we want to do is create a new repository to effectively push our committed changes into GitHub. So what I'm going to do, I'm just going to click on repositories, and then I'm going to create a new repository, and I'm just going to call it dating app. And we can give it a description, and we've got the option to make it public or we can make it private. If you make it private, then nobody else can see your code. And because this is a training course where you may want to get assistance at some point, I'd suggest that you keep it public, because if you do run into a problem, for example, and you say, hey, I'm stuck on this, and you've got your repository private, it makes it difficult for you to share the code, because then you have to specifically invite people. Whilst you're developing the application, you can set it to public, and then after you've completed, you can set it to private if you wish. But I would suggest keeping it public at this point. And then we can go ahead and create a repository. And after we've done this, we get some instructions about what we need to do next. Now, we've already added an init. We're not going to add a README at this time. We've committed our code. We've used the git commits. And what we'll do next is we'll use the git remote add origin to tell our project where its remote repository is. And what I'll do is just copy this into my clipboard. We'll go back to our terminal, and I'll just clear the window here and just paste in that command and then press return. And we go ahead and add our origin to our code. What we can do next, if we just go back and take a look at what we need to do, then what we can do is use this command, which is to push upstream to the name of our repository, the origin, and the branch that we're using is master. And we'll just copy this line of code as well, and we'll go back to our terminal and we'll paste this in. Now, you may get asked to authenticate here. I've got an invalid username or password. And if this happens, then what you can try is just go back to version control. And this time we'll use the VS Code option to push to, and we'll choose our origin here. And what this should do is ask us for the password. And then what we can do is just simply paste in our password, and this should then authenticate us to GitHub and push our code up to the repository. So what we could do then is we can just head back to the browser and we can refresh this page. And what we should find is that we've got our code changes added into source control for the end of section 2. And if we click on the API folder, we can see all of the information going on there. And what we'll do next is we'll wrap up this particular section with a summary. So we've reached the end of section 2, and we're just wrapping up with a summary here. What we want to take a look at is what our learning goals were at the start of this section, and what hopefully you've got an understanding of now. So we've implemented some very basic API functionality, and we've used the .NET command line interface to create our application, and we've used it to create a solution file, and we've also used it to create a git ignore file. So the .NET CLI is a very useful tool that we'll be using throughout the development of this application. If you're using Visual Studio or you're using Rider, you might prefer to use the built-in tools to run your project, and that's absolutely fine. But VS Code doesn't come with any tools like that, so we use the .NET command line interface to do so. We also took a look at API controllers and endpoints. Hopefully you've got an understanding now of the different parts of an API controller. An API controller inherits from a controller base class. An API controller has an API controller attribute, and an API controller has different endpoints. And we return action results from our API controllers. Now we'll be looking at API controllers in more detail throughout this course, So don't worry if you feel like we haven't covered every possible aspect of them just now. I could say the same about Entity Framework as well. We've barely scratched the surface just now, but we have installed Entity Framework and we have managed to get data from our database using link queries, which then get translated into SQL code. We've also taken a look at the API project structure. We know how our application starts. We know the important classes that are involved in the starting of our API, the program class and the main method. And we've also taken a look and used configuration and environment variables. Well, not so much environment variables, but what we're storing our configuration in just now is the appsettings.development.json file. That's one of the places our API looks to get configuration from. And then to wrap up, we've saved our changes, the code that we've written, into source control, and we've pushed that on up to GitHub. And this wraps up section 2. What we're going to take a look at next is creating our client application in Angular, and we're going to take a look at getting our data from our API all the way into the client browser via our Angular code. And that's coming up next.